All right, today we're going to take a look at probability and the idea of something being fair or not. And when you're dealing with probability, something is fair if it has the exact same probability no matter what outcome you're looking at. Okay, so one of the reasons a dice is used, or dice is used all the time in games, is that it's fairly fair. All right, if I'm rolling one dice, I know that there are 6 different outcomes that I could get. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Now, the probability of each number is 1 out of 6. There are 6 total sides. I have a 1 out of 6 chance of getting each number all the way down. So we would say, yes, boom, that is a fair activity according to probability. Okay, but let's say the game was a little bit different. Let's say the game was, hey, what is the probability that I would get a number that is bigger than 2? All right, bigger than 2. That means a 1 or a 2. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. So if the game was, hey, can you roll a number that is bigger than 2? I know that I have a 2 out of 6 chance of getting a number smaller, or 2 or smaller, because it said bigger than 2. And I have a 4 out of 6 chance of rolling a number that is bigger than 2. So this would not be fair because our probability is different. One side has an advantage over the other. Now, many games, that's okay. But in terms of that, that would not be fair. So your idea today, your first question is, I want you to think about rolling 2 dice. We do it all the time. Games like Monopoly and Risk and the game of life roll 2 dice all the time. So I want you to figure out, well, what is the probability of rolling each of these different numbers? Okay, now it's a little bit tricky because you have to think about it. So let's do a couple together. I listed all of the different combinations I could get. I can get a number anywhere from 2 to 12. I couldn't get a 1 because the lowest you can roll on each dice is a 1. So the lowest it could be is 2. The biggest is 6, and 6, which equals 12. So let's think about all of the different possible outcomes. Okay, how many different ways can I roll 2? Well, there's only 1. I would have to get a 1 and a 1. Okay, you might think at the beginning, oh yeah, everyone might have the same probability, but they don't. All right. If I think about the number 3, how could I roll 3? Well, I could get 1 on the first dice, 2 on the second dice. Or I could get 2 on the first dice and 1 on the second dice. So I have 2 different outcomes that could get me the number 3. What about the number 4? Well, I could roll 1 on the first dice, 3 on the second dice. I could roll 3 on the first dice, 1 on the second dice, or I could roll a 2 on both dice. So I have 3 opportunities to roll a 4. I could go a 1 and a 3, I could get a 3 and a 1, or I could get a 2 and another 2. Okay, I want you to figure out the rest of this, and then you're going to fill out a chart telling me what is the probability of every single number. Now, you won't know that probability until you figure out how many different outcomes there are. Remember, it is the desired outcome, the part over the total, when you're dealing with probability. Okay, so this is your first task. Go and see if you can tell me the probability of rolling each of these numbers.